Welcome to video 7 on the FCEditor Complete Guide series, where I'll be explaining everything you need to know about making custom future cop levels in FCEditor. For this video, I'll be talking about the path, entity behavior, and navigation meshes. So let's get right into it. In the last video, I covered all major behaviors except for one, pathed entity. Pathed entity is a behavior that allows the actor to use a navigation mesh. There is a dedicated edit mode for modifying nav meshes, but before we do, let's talk about how they work. Navigation meshes are basically just a bunch of nodes that point to each other. A node is a point on the level that's used as a destination. The node then has other nodes that it will point towards creating a path. Think of it like a chain from point A to point B to point C. A node can have a maximum of 4 different paths, and if a pathed actor gets to a node with multiple paths, it will randomly choose one. The node's position is groundcasted, however nodes do not have a height offset, and instead use a traditional y-axis for its height. This will be explained more later on. Pathed entities are the actors that can utilize navigation meshes, but their behavior is somewhat strange. By default, pathed entity's speed can fluctuate a lot depending on its circumstances. Things that can change its speeds are turns, long distances, and obstacles. There are properties that control these speed changes, but their functionality is unknown. Pathed entity also provides different functionalities mimicking both air and ground vehicles. While nav mesh nodes do not have a height offset, pathed entities do. If a pathed entity has a height offset, it will treat the actor like it's flying. Whenever a pathed entity with a height offset is not pathing, the actor will move vertically to land. If the actor starts to path, it will move vertically to take off and start pathing. To my knowledge, there's not a way to override these behaviors, and it can be tricky to manage for actors that are intended to hover and not fly. To learn more about pathed entities' behavior, check out the actor properties document. Let's actually see this all in practice. To view and edit navigation meshes, we'll need to switch to navigation mesh edit mode. Switching to this mode, we'll see a bunch of colored lines and white circles. The white circles represents a node, and these colored lines are paths from one node to another. These lines will show the direction actors will move in by the arrows. The pathed color represents the different options the actor can take. When first loading into Nav Mesh edit mode, it will show the existing first navigation mesh in the level. Let's create a completely new navigation mesh to make our own paths. At the top, there's a plus tool next to a dropdown. The dropdown is for choosing a navigation mesh to edit, and the plus will let us create a new navigation mesh. When pressing the plus, the dropdown will open up showing the new nav mesh requesting a name. Once we give the nav mesh a name, we can switch to editing that nav mesh with the same dropdown. We aren't going to see any nodes or paths because the nav mesh we added is empty, so let's add some. The first tool in this mode is to add a new nav node. Once pressed, a node will be created and it will follow the cursor for placement. Hit the left mouse button to place the node. We now have a single node in our nav mesh, but this isn't very helpful without other nodes to connect to, so let's add some more. Now with a few more nodes added, we can connect them together to create a path. To start a new path, right-click on a node and then move the cursor to another node and left-click. The line will turn a color, and we have now just created a new path. When creating a new path, you may have noticed that there is a node that follows at the end of the path. Instead of adding nodes and then making the path, a new node can be added just by starting a path and clicking on the level. These are the methods for adding nodes to a nav mesh. But many times, these nodes need to be edited. To edit one of these nodes, we'll first need to select it by clicking on it. The node will highlight green, and the same axis mover from Actor Edit mode will also appear here. Just like with Actor and Actor Edit mode, we can move nodes the same way. An axis can be clicked and dragged to move the node in a certain direction, or left shift can be held to move the node to the cursor. The node can also be locked to a grid when moving by holding left Alt. If a node's path needs to be changed, hit the Clear All Next Node Paths and reconnect the nodes. There's much more that can be done with nodes, but for basic navigation meshes, this is really all we need. Let's see some of this in action by having a pathed entity actor use this nav mesh. In actor edit mode, we'll need to use any actor that inherits from the pathed entity behavior. I will be using just a precinct assault tank. First, we need to tell the actor what navigation mesh to use. In references, there will be an option to select a nav mesh. Now that the actor knows what navigation mesh to use, we next need to tell it which node it can start to path on. FutureCop's method for this is a little strange. The actor's position must be point perfect with the position of a node. If the actor doesn't have any positions that match nodes, it won't spawn incorrectly. Luckily, the editor has some tools to combat this very thing. In Nav Mesh edit mode, we can copy the position of a selected node by hitting the Copy Nav Node Coordinates tool. Then we can switch back to actor edit mode and paste the position with the Paste Nav Node Coords tool. Now that the actor's position is the same as a node, it will spawn in and start pathing. You can also paste the node's position onto other nodes in Nav Mesh edit mode. Let's move on to some more advanced topics on navigation meshes. You may have noticed this small window that changes data when selecting a node. This window is the node's property view. The header contains an index label with 4 other buttons that either give a number or say none. Nodes uses indexes to reference other nodes and create paths. What this means is all nodes in a nav mesh are in a list, and a node's index is what order/position the node is in the list. The index label shows the index of the selected node, and these buttons are the indexes for the paths to the next node. Nav node indexes are only relevant in scripting, so these numbers can be ignored unless you're modifying the nav mesh via scripting. However, these buttons allow you to jump to a nav node if pressed. This can help in seeing how a navigation mesh is set up and where the destination of a node is. Next in the property view is a drop-down for something called a state. A nav node state can either be enabled or disabled, and it tells the actor if it can path to the node. If the state is enabled, the actor can path to the node no problem. If the state is disabled, the actor cannot path to that node, so it will either stay put at the current node or path to a different node if available. The node will also appear red showing that it is disabled. There is one option titled Unknown that was added for compatibility. This option can be ignored. Next is the node's groundcast. Groundcast was explained in the last video, but briefly, groundcast is the method used to attach a node onto the level. Pathed entities do not have groundcasts of their own, and instead use the data on the nav mesh. The dropdown gives the option for highest, lowest, middle, and this new option titled lowest y-pos. Nav nodes do not have a height offset, and instead use a y-axis for its height. There are many reasons to use the y-axis, but it's most commonly used for actors that are meant to fly or to make the actor travel vertically. In order to get the node to use this y-axis, the groundcast must be set to lowest y-pos, and read y position needs to be checked. When doing this, a new yellow circle will appear vertically from the node. This yellow circle is the node's true position with the y-axis. We can change the y position by either typing in the position field or by dragging the green axis on the node. The coordinate space the y-axis uses is the same as the level's vertices. Even though pathed entities do not have a groundcast and use the node, they do, however, have a height offset. This means that not only can the actor use the node's y-axis, it can also offset that position with a height of its own. With Navigation Mesh Edit mode, we now know all the edit modes in FCEditor. We can edit the level, actors, and now navigation meshes. But there's one last piece that glues everything together in a level. In the next and final guide video, we'll be tackling FutureCop scripting. If you have any questions or would like to see more FutureCop, consider joining the Discord linked below. I'll see you in the final guide video.